Hmm. So today we are going to discuss about onto functions, right? In functions, we are already done with one function. So now it is onto function, right? Onto function. Onto function means surjective, basically, right? In one function is known as injective function, and onto functions are surjective, and surjective and injective functions combinedly known as bijective functions, and bijective functions have inverse, right? So these all are done to find inverse of a function. A function of a means an inverse of a function is only exists when the function is bijective, right? So that is why we are doing onto functions. So onto functions are important. Now let's understand what onto function is and how they are important to find injective to inverse, right? So what we can do, so let's say there is a function, let's say a and b. Let's say there is a function f such that a to b means if we substitute, a is basically domain and b is basically range. So in a function a to b, a is domain and b is range. What do you mean by domain? Domain is all the possible values that can be inserted, right? And b is the possible values of possible values of f function, basically what we can get, right? So let's understand how what is surjective function is. Now, so in surjective function, what we do is we just interchange the functions, right? Like this, b to a means we get a new function g such that b is b for domain b, and check what we are getting from the range, right? We are going to get a function g such that b is domain and a is range. Let's have some example, and then and after that you are going to get it, right? So let's say there is a function function fx is equals to 2x plus 3, and for this function n to r, right? If you insert you are inserting the natural number, then you are going to get range as r, right? So here if I compare this with this, so this one is the natural number and this is going to be range, right? If you put any value of x as a natural number, then fx is going to be a real number, right? Now what is the criteria is, you just put it as a, let's say, y, right? 2x plus 3 as y, and now the value of x is going to be y minus 3 and y minus 3 upon 2. This is what we get. Now it is a new function, right? You can say that it has a gy is going to be y minus 3 upon 2. And if you try to understand, for here x belongs to natural number and y or fx both belongs to y. That is what it means by range, right? Now this y is here, means for this particular function y is domain. So for g, y is going to be domain, and this is actually equals to x, which is this is going to be a range. For this particular function x is range, but x belongs to n, so that is why g should belongs to n, r tends to n. Now if this holds true for this particular function, if this holds true, right, gy for gy equals to this, if this condition holds true, that means this function is onto, right? I will let you know what is the importance of onto function in finding the inverse, but for understanding that, you need to understand this first, right? So let's check. If I substitute y from any real number, is it possible that every time I will get x as a natural number? Is it not? It is not, basically. How? If I substitute y is 0, I am going to get minus 3 by 2, which is not a real number. It is a natural number. Sorry, it is not a natural number, and in fact it is not a natural number. So that is why it is. Now for all, this is a simple for all y belongs to r, gy does not belongs to natural number. Hence gy, hence, so this is for gy, right? So this implies for f, hence fx is not onto function, right? So this is what it means by one onto functions, right? So let's have some more example, and after taking some several examples, you are going to understand what do you mean by onto functions. So this is how you can do this. Let's have one more example. Now fx is equals to let's say 2x square minus 5, and gx is and the function is such that it is real to real, right? Real to real. Now let's check. So what you can do, you just take fx equals to y. Now 2x square minus 5 is equals to y. So 2x square is equals to y plus 5. So x square is going to be y plus 5 divided by 2, right? So x is going to be, now x, what is x? X is going to be square root of y plus 5 divided by 2, right? And for this particular function, you can say that it is a new function as a gy, and for gy, what is y? Y is range of this. So here the both are same, so the change will not be visible very clearly. So but you can think of it like by doing so, gy is always going to be the domain and range goes interchange, so r to r. Now is it possible that every time when I substitute y as r from a real number, is x is always going to be real number? It is not true, isn't it? Why? Because if I substitute y equals to minus 10, so minus 10 plus 5 minus 5 by 2, minus 5 by 2, square root of minus 5 by 2 is not a real number, right? It's an imaginary number. So for all y belongs to r, gy, right? You have to check, you have to say about the gy. Gy does not belongs to r, hence, right? Hence fx, and you have to tell about fx. Fx is not onto, right? You can give an example as well, right? If you want to tell some example. Now y equals to minus 10, or you for the just you can write it like this: y equals to minus 9, which belongs to real number. Minus 9 is real number, that is okay. Now but gy is going to be square root of minus 9 plus 5 divided by 2, which is square root of minus 2, right? Now under root of minus 2 does not belongs to real number, hence, right? Hence fx is not onto, right? Or right, it is not onto function. So this is how you can do check whether it is onto or not, right? Now let's understand what is the role of onto, means how can you say that onto function is like, means what is the importance of onto function and one function in calculating the inverse, right? So let's check. Now let's say there is a function a comma b, right? So what is the possibilities, right? There could be one function. It is possible to have a one function. And now the second thing is there is a possibility of many one function, right? If you substitute many values, you are going to get many, right? Like this. It is possible, right? So it is 1 and it is onto. And what do you mean by inverse? Inverse is basically like interchanging the domain and range, right? So if I say fx is equals to 1 upon x, then the inverse is going to be, means if you insert from real to real, right? Or I can say, let's say 1 plus x divided by 2. Let's say function is this, right? So what do you mean by inverse? Inverse for this, let's say r to r, right? R to r. So if you insert a real number, you are going to get in real number. Now what do you mean by inverse? Inverse means basically if you interchange the domain and range, the new function doesn't have any, means like it will also exist. If you interchange the domain and range, then it will also exist and it will work fine. But if a function is not 1 1 and, right, 1 1 and not onto, then it means it is not possible to have a inverse of a particular function. It is not possible. Let's see how. Now let's say it is not 1 1, it is many one. It is many one, right? Let's say it is a many one function, right? Now what you can do, 1 1 and many one. Now if we interchange domain and range, right, if we interchange, so it is going to be over here and this is going to be over here. So what's the what is here? Here one value will have 3 values and one value have 2 values because of this, right? So if you interchange the domain and range, this is what you are going to get. But it is not possible for in a function. It is not possible if you substitute means for a function fx, let's say any value, any constant value cannot give you 2 different value. It is not possible, right? That is not a function. That is not a definition of a function. So it is not possible. So that is why a many one function cannot have an inverse, right? So inverse means a function which is many one, not 1 1, cannot have a inverse, right? But in case of 1 1, let's see what will happen. Right, each and every identity means every single entity have mapping with 1. So if you interchange this over here and this over here, again they will be 1 1. Means it is possible that each domain have a particular range. Means for each value there is a specific image for each. You are getting this, right? So this is how you can think of many one function cannot have inverse, but 1 1 can have. Now let's check about the onto function. What happens with onto function? How the inverse of onto function exists? Means why a function should be onto, right? Now for understanding purpose, let's say this is let's just drop everything. Let's see, there is a 2 function, let's say a and b, right? And just for understanding, let's keep it as function is such that natural to real, right? Natural to real, and function is defined as x square. That is very simple and a famous example, right? Now just for illustration purpose, I'm just going to get some values, right? Natural numbers start from 1 2 3 4 5, right? Now b is a real number, so it will have all numbers which is lying on a line, right? So it will start from minus like -4 5 -4 -3 and so on, like this, right? And it, of course, it will have 1 4 and let's just for the simplification purpose I can write it like this. This is going to be this -1 -2 -2 -1 0 1 2 and 3 4 and so on 9 and so on 16 and so on 25 and so on, right? This is how it will appear. This will be what b is, and the mapping will be like this. Just for the illustration purpose, I am taking something like this. 3 is 9, 4 is 16 and 5 is 25, right? This will be the mapping. Okay, so because of natural number, this function is because the mapping is from natural number. This function is 1 1 but not onto. Why? Now in onto function, what we do is we interchange the domain and range, right? So if I take it as a y, so y is going to be root x, and so x square equals to this, sorry, this should be y and this should be x. Now this is your new function and you can write it like this. Now so this is a new function and y belongs to real number, so that is why for this particular function real number will become domain and range will become a natural number, right? Now if I take it like this, so this is going to be b and this is going to be your a. What is a? A is natural and b is real, so it will start from minus infinity 0 1 2 3 and so on, and it will go till infinity, right? So minus 2 minus 1 like this, and here only natural numbers. Natural number is 1 2 3 4 5, right? Now if I substitute a real number, let's say minus 2, then there is nothing, right? Nothing, no value in natural number in a from to which I can map the value of y, right? So there is no value of that, so the function doesn't exist, right? So this function is not onto. Okay, so this is how we understand what is onto is, right? So in order to exist function have a inverse, it is important when the domain and range interchange, the means the function exists, but here the function is not existing because of if I substitute y equals to minus 2, any negative value, so in that case the functions fail. So that is why it is important to have a function to be onto in order to have inverse, right? Now there is some important question I will tell you later, but till that time try to solve this question that I am going to give you. Okay, I will means give you some questions in the description of this video. You can try to solve it by yourself. Later on I will post some more videos on problem on this one function and onto function. It is better and how the inverse exists, right? So inverse is a very important question in NCERT and CBSE exams, so you need to know how the inverse we calculate inverse. Okay.